Ladies and gentlemen, dear colleagues, dear all, good afternoon to you all and welcome to our seminar organized within the seminar series Xenergy. This is our local name. Today it's in Czech, but today the presentation will be in English. So I would like to present you a distinguished guest with great experience in the nuclear power industry. Our guest is Jeff Harper, Vice President for Strategy and Business Development at X-energy. Welcome, Jeff. I will say a few more words about you, and then I will let you speak and talk about your presentation. So prior to joining Xenergy, Jeff worked at the Westinghouse Advanced Reactor Program, where he was responsible for commercial development of PBMR high temperature gas reactor project and its small modular light water nuclear reactor program. Jeff was also founder and CEO of the Turner Harper Associates, the global engineering firm serving a client list that included what is important and interesting for us, Partner for Energy in Czech Republic, Chess Group, also South Africa, ESCOM, Lockheed Martin, and Bechtel Jacobs. Jeff also served as a vendor inspector for the U.S. Nuclear Regulatory Commission, where he led more than 30 technical and quality assurance inspections and audits of the nuclear power plants. Nowadays, Jeff is also Vice Chairman of the U.S. Department of Commerce Civil Nuclear Trade Advisory Committee. He serves on the Nuclear Energy Institute Suppliers Advisory Committee and Trade Advocacy Subcommittee. Last not least, Jeff is a frequent speaker on advanced nuclear. So it's a big pleasure to have you here. I know that you had some traveling and some time difference, so you will tell us, and I will not keep more time. So thank you, Jeff, very much for being with us, and the floor is yours. Thank you.
Well, thank you very much, Jenna, for putting this wonderful forum together. I know you've worked hard at it, so I really appreciate being here. Technology is awesome when it works properly, but at least it works. And I'm here with you from Idaho Falls, Idaho. And so greetings from here. Again, really appreciate the opportunity. We are, I'm going to be able to be with you until about 2:30 your time. So I apologize in advance if I have to leave early without answering a lot of questions. Happy to answer any questions. But in the event that I'm not able to answer questions, then please feel free to send them to me, to email them to me. So again, thank you very much. What I wanted to do is just talk to you today about Xenergy and our quest really to deploy our Xe-100 this decade. Very important. What we've seen now and globally actually is that this is a new era we're looking at. Timing in life is usually everything. And at this time, it seems like, especially in the United States, we have an administration, in the Biden administration, who is truly fully bought into the green energy revolution. And then, of course, we have the technology and the SMR, small modular reactor. Specifically, I'm really all about the high temperature gas reactor technology. This is obviously nothing new. You all know that. And so the technology is there. And again, globally, we have clear signals about climate change. We're seeing globally the net zero requirements that are coming at us from all different countries. 2040 to 2050, we're seeing that you know, countries and companies are looking at net zero. So all these things are sort of working together and really giving us an opportunity to make a difference. I like to show this slide in times when I give these type presentations, although you know, this is somewhat dated from 2014. The UK National Nuclear Laboratory, they did a really good job on their SMR feasibility study report. But you know, just looking at the demand globally, the potential demand globally for SMRs, you know, 65 to 85 gigawatts by 2035. It's, you know, it's a healthy market there. You know, half billion. I've seen numbers that are even higher than this. The key here is that there's tremendous demand out there in the marketplace. Also like to take a step back and really think about nuclear. This always motivates me personally when I really look at the power density of our fuel. Our fuel obviously is TRISO fuel, and in a pebble form, we call it a pebble. Actually, it's the size of a billiard ball, as you all well know. But look at the scale of power density here. I'm always amazed when I look at that 2.66 metric tons of coal. It's extraordinary, and especially when you think about CO2 emissions and tons of ash, and the fact that we have approximately 220,000 of these in our reactor at any time. So it's imperative, especially in this green energy revolution, that we use nuclear power. In fact, I would go as far as to say that you're not going to be able to achieve the net zero emissions goals that are out there without the use of nuclear power. I don't want to get too much into this technology. You all are well aware of this, but we really, just to show here that we really believe that our safety case is in our fuel, which is actually a game changer. We are planning on early licensing our reactor, you know, with the idea that the regulator may not accept all of our claims in terms of this sort of principle or theme, but we are clearly looking at capitalizing on the fact that this TRISO fuel is so robust, and that we should make our safety case focused on that fuel. Just for those of you who may not be familiar with Xenergy, just wanted to give you an overview here. The company really has 4 different product lines, if you will. The first one being the Xe-100. And the Xe-100 is a high temperature gas reactor, pebble bed modular reactor. And we have our standard plant is 4 of these modules, each module being 80 megawatts electric, so that gives you 320 megawatts electric. We have the Xe Mobile, which is the Xe-1, we call it, and that is approximately 1 megawatt electric, and but it's specifically now for defense applications. We also produce the TRISO fuel, so we have we call it TRISO X, which is our fuel manufacturing capability. And finally, we are really in the space applications business. So what that means is that we have, we're using the TRISO fuel for thermal propulsion and also for fission power from lunar surfaces. So if you know anything about Xenergy, you realize that the founder of the company, Cam Gatharian, really started the company in 2009, but he had his career up to that point was in space application. In fact, we call him a space cadet. He had started a business and grew it to probably $600 million a year business, and basically supplied NASA with engineering services, and really felt compelled to give back to humanity in terms of dealing with the carbon issue. So he did a study for a couple of years and figured out that really nuclear was the way to tackle the problem, and eventually focused on this technology that we have. And so through his philanthropic efforts, we are basically grown to where we are today. Again, just by way of talking a bit about the Xe-100, it's again 200 megawatts thermal, 80 megawatts electric. And the exciting thing about what we can do with this technology, as you all know, is capable, obviously, of producing electricity, but this process heat, which is really high quality, 16.5 MPa and at 565 degrees C, that opens up a lot of non-conventional or non-traditional applications for nuclear power, specifically water desal, petrochemical applications, district heating. And you'll notice I've left hydrogen production for last, simply because that is something that we aspire to, and we believe that we can get there with minor modifications, minor modifications to our technology. I think the future is really in the hydrogen production. We're hearing a lot of market signals about this, and we do intend to pursue this with, especially with the petrochemical industry. The other thing that makes ACGRs and specifically Xe-100 very exciting is the ability to load follow. So in our case, we can couple with wind and solar and provide a ramping from 100 to 40%, 5% per minute. So we are actively talking and working with renewable energy companies right now, trying to see how we can couple the technology and serve the market. In fact, I would say a lot of utilities in the United States, to name a few, Duke, Dominion, they all are really focused on renewable energy, and it's really up to us, and they challenged us to be able to work with these renewable energy companies and provide them with their carbon-free energy as they require. So it's a new world, I think, in terms of nuclear applications. This again just shows basically the same thing here and some of the other parameters. One thing that's really good for us is we don't thermal cycle the plant, and we're doing this load following, which is really great. Just somewhat of a busy slide here, but just wanted to give you just a feel for the layout, typical layout of our standard plant. And you see you have a reactor building, a turbine building. So that's sort of one module there. And we spread those out, of course, with 4 modules for a standard plant. You all are definitely welcome to visit us. Our headquarters is in Rockville, Maryland, right outside of Washington, D.C. And also, we're literally a few Ks from the U.S. Nuclear Regulatory Commission. So I think when COVID is allow us to travel and so forth, please come visit us. And we'll definitely roll out the red carpet for you. So I wanted to talk about what's important in my view is deployment this decade. So at Xenergy, we have, as we like to say, 3 shots on goal with the hopes that we can score in all 3 situations. First, we'll start off with the Xe-1. So we have been down selected with BWXT for a procurement possibility, really a deployment possibility with the Department of Defense, the U.S. Department of Defense. There were 9 competitors, and out of the 9, the 2 of us were selected, and the Department of Defense is actually paying us to finish our design of that reactor. And by March, we're hopeful by March of next year, they will either select Xenergy or they'll select both of us for a 300 megawatt market demand from DOD, Department of Defense. So 1 megawatt, 300 megawatt market is pretty good through 2040. The other 2 opportunities happen to be centered around the Xe-100. We have one in Canada, and this is at Ontario Power Generation, OPG. OPG has plans to deploy an SMR on their Darlington site, right outside of Toronto. And what makes Canada so important, and it's really a great market. The Canadians have done a tremendous job in terms of their clean energy goals. They have a carbon tax there. So really, we're looking at a situation where Saskatchewan Power and Alberta province are really looking at fleet deployments, and they told us that. So it makes this first project at Darlington very important. All expectations are that, you know, sort of winner take all in Canada. If we are able to be successful being selected here, then chances are good, not 100%, but good, that we'll also get a substantial amount of the fleet deployment that we expect in Canada. So there were 10 competitors that were very serious competitors, and out of that, OPG selected three companies, ourselves, GE Hitachi, Terrestrial Energy. And so we are supposed to be told this year who will be the winner of that particular competition. So we'll hope for the best for Xenergy, that we'll be successful in this year. And finally, we have the here in the United States, the U.S. Department of Energy launched a program called the Advanced Reactor Demonstration Program. And in this program, they were obligated to cost share or provide 50% of the project cost. In our case, it would be to actually commercialize our fuel facility. We already have a pilot facility for our fuel, to finish the licensing or to finish the design and also the licensing of the reactor and then construction and deploy. So the total price tag would be somewhere in the neighborhood of $2.4 billion. And the Department of Energy has provided $1.2 billion or will provide $1.2 billion for that particular project, for this deployment. So 37 companies were in the competition. It was very fierce competition for this. We found out late last year that we were successful along with Bill Gates' company, TerraPower. So both of us independently will have projects where the government, DOE, will pick up 50% of the cost, the total cost for the project. Now, what's great about these two projects, in my theme, deployment this decade, OPG is really looking at a deployment date of 2028. So in nuclear time, that's right around the corner, 2028. With the U.S. Department of Energy and this program, they are required that we deploy our reactor project by 2027. So that's even more aggressive than the OPG Darlington project. So what happens with what we're doing with the DOE program? Currently, we are partnered with Energy Northwest in Washington State. And as you see here in the left lower, this is Washington State. For those of you who don't know it, it's the west coast of California. And we are looking at a site here, as you can see. And so this is, again, Energy Northwest is the utility group. And so we're looking at a 2027 deployment for that. You can see here the cost share, 50%, $1.2 billion by US DOE. We're looking at approximately $300 million in terms of our non-recurring engineering costs and regulatory costs, meaning the licensing, and then the balance will be picked up by Energy Northwest as such through municipal bonds, and then they'll pass the cost to their ratepayers. So we're really excited about this prospect, and it gives us two opportunities to get our first of a kind completed. As I look at, our situation at Xenergy, I really look at it in three different buckets or spheres, if you will. And you have to get them all right. You have to get them all down. They're equally important in terms of deployment. So we start with the technology. The technology has been around a long time. We have engineering resources that are dedicated for years and years looking at this technology, and it's Xenergy from 2009 to 2009. So, we have a fairly good understanding of what we need to do in that sphere. On the regulatory side, which is the licensing, and also we have a public acceptance, sort of goes hand in hand with the technology. If your design is sound and you submit a good application, a superior application to, in this case, in the United States, the Nuclear Regulatory Commission, then, you know, that's manageable. We do have risk there in terms of not being able to dictate the time, the schedules. We can lay out a schedule, but obviously the regulator is basically on their time scales. They talk about 36 months for reviews, but it all depends on your application and responding to their questions. But the area that is somewhat virgin, if you will, or I would say the new frontier, and the area that I'm predominantly focused on is the commercial. And so this is the other leg of the three-legged stool. You get the two legs and you still fall if you don't get the commercial leg correct. And so we really have been focused a lot on what it takes to successfully deploy this technology in the marketplace from an economic standpoint, and also from just commercial applications and dealings. So having said that, obviously cost is a huge deal. I mean, if you don't get the economics right, it becomes a research project, and Xenergy is clearly not in the research business. We leave that to smarter folks than we are. So our cost model, we get a lot of questions from our potential customers who've done due diligence on our cost, but we follow the IAEA Generation 4 cost accounting guidelines. And what we do is the components that really make up 80% of the cost, we work with our supply chain, and basically they give us quotes. They give us quotes for all of those components, systems, structures. In some cases, they're willing to give us liquidated damages, even at this stage of the game, which is quite remarkable for their quotes. I would say the cost estimating is based on American Association of Cost Engineering, and our estimates are level 2 or 3, which it's a 5 scale, 5 levels. 1 being the most certain and 5 being the less certain. So, you know, we're looking at very mature cost estimates. I would say the most mature beyond building. I mean, once you build, then you definitely will realize that, you know, perhaps there are cost estimates that need to be improved, etc., especially in the first time. We recognize that, but this is really the best we can do at this stage. We rely on our EPC partners. There's Burns & McDonnell. We're working with Zachary and other companies, Hatch, to develop our installation factors. And also contingency is always a huge deal. How much contingency do you put on your estimates? 15%, I've seen 10%. I've seen some estimates that really don't have contingency, which I believe is a mistake. But anyway, we use NPR for the most part with that, and Monte Carlos, and they're using the Monte Carlos model to to come up with what they believe the appropriate contingency factors would be. So, yeah, I would say also that as far as our LCOE is concerned, we use the U.S. Department of Energy formula to arrive at that number. We are generally between $50 and $60 per megawatt hour for our LCOE. And again, this is an area where the reactor developers, there's no sort of required standard in how you approach, reporting these numbers. This is our approach, and I believe it's fairly conservative, if you will. But some others might calculate their numbers differently, and so at Xenergy we're very conservative about this. There are also, as we see, some cost reduction opportunities that we have. There's on the construction side, we're looking at a vertical shaft boring machine for below grade, to put the reactor below grade. And we estimate there be some 25% savings that we could achieve. So we're actively looking at that possibility. There's also on the pressure boundary system, largely because we believe that the safety case is in the actual fuel itself, the pebble. We're looking at a possibility of going from ASME 3 to Section 3 to Section 8. And that would be a huge savings if we're able to achieve that. May not be able to do that on the first of a kind, but we're working toward that. As far as the pebble price, we're always striving to reduce that price and bring the overall price of the reactor and make a better reactor economics there. So there may be some opportunities. We're believing in the fabrication process. This is more of a batch process and sort of a continuous process just by the nature of it. So we're looking at ways and means of addressing that. And also, transportation costs are a huge deal as well. Especially here in the States where you have, you're transporting from different states which maybe have different requirements, and then you have the federal government has their own requirements. So we're trying to tackle that as well. That could be estimated around 20% savings. So I would say from a technical point of view, these are what we call the low-hanging fruits at this point in time. In terms of the big one, though, that I think would have a major impact on our LCOE would be the ability to reduce our staff. Right now, for the standard plant, we're looking at, with operators, engineers, maintenance, security, we're looking at 179 employees, FTEs, employees, full-time equivalents, to getting that number down to about 84. And I think we can look at automating some of the activities, looking at how we can use the so-called super crews for maintenance purposes. And this one is very interesting because it's sort of a compromise from what is the goal, I think, from a public policy standpoint. Obviously, governments, locations where we're looking to site, they'd like to have more employment. So the more people employed, the better off it is. From a tax generation point of view, that's on one hand, but then on the other hand, it drives the cost of our LCOE. It drives that cost up, or at least the price up, and the cost and the price up both. So, it's a balancing act, but we're hopeful that because we're looking, our real goal in all of this deployment is really to deploy fleets of these reactors, because unlike the large light water, which the economics looks better with the economies of scale, where our economics look better with the economy of volume. In other words, the more we deploy, the more economic benefit, the more cost reductions we can get. So, and as it is right now, our materials for the reactor and the plant are not very interesting. I mean, we're looking at off-the-shelf materials for the most part, and graphite, matrix, etc. So, or sleeving for the reactor. But you get the point. The point is that we're going to err on the side of trying to make this reactor as economic as possible, and try to actually make up for any decrease in employment per standard unit by deploying fleets of these reactors. So again, within the sphere, again, remember up front I showed you the three spheres, the technical, the economic, and the commercial. I'm trying to focus here on the commercial, given this is where we're going to be either successful as a business or not successful, and especially in deploying this decade. So, having said that, again, trying to look at where this technology with its attributes, its positive attributes, will make a difference, and actually how to work with the potential customers in each market. So if you have the electric power utilities, I mean, it's really more of a build, operate, and transfer model that we would offer in that situation. And again, you're looking at various ways to structure deals with the utilities, whether could be a technology licensing agreement or others. But again, this build, operate, transfer model is one that is pretty predominant there. Again, financing is it's always an issue, but again, this is virgin territory in terms of the SMR. And Xenergy right now has been funded primarily through Cam Gafarian, who I mentioned to you before, who's our founder. We are actually in the midst of a capital raise right now, Xenergy. So we are just about, I think we're closing what we call round B of our capital raise. It's either closing this week or next week. I believe this week it's closing finally. But the round A, as such, would be Cam Gafarian. Again, he put about $85 million of his own money into Xenergy. Plus, we had the various grants from the Department of Energy that helped us achieve a lot of the advances in the fuel pilot. Well, it helped us establish our fuel pilot facility, as well as also advancing the design. But, you know, and then I should say that we will be going out for another round of financing probably toward the end of this year. Round B, I'm happy to say, was a successful round. So in that, we raised approximately $120 million, and we'll have another probably $170 million or so to go in round C. So that's on the enterprise side. But then on the project financing side, again, for these projects, we're going to have to be innovative in terms of the project financing. Right now, with OPG, that project, obviously OPG is it'll be a straightforward transaction. They will end up owning the facility, and so they will pass the, they'll finance the project. And Energy Northwest, it's similar. We'll probably end up, and this is to be determined, but putting together a project company with Xenergy as well as Energy Northwest, and at some stage we'll probably that let's call it a project company will own the facility, and then probably at some stage it will be transferred over to Energy Northwest. Those plans are right now being formulated. But I just wanted to say just a couple of words about the other two markets that, quite frankly, we've not done anything with. Okay, so one would be the industrials, meaning the integrated energy system. So the process heat that we're talking about earlier, it remains to be seen. If you are working with, for example, a Dow Chemical or some other large petrochemical company, or if you're into water desalination, we know that the enterprise, Xenergy, will be financed, but in terms of the project itself, what's really unknown is how we will structure a strategic partnership with these entities, because these entities really don't have nuclear experience. So perhaps we're looking at a build, operate, manage model. And so that's going to require a new paradigm or a new thought process in terms of how we actually implement this partnership and deploy our reactor. These aren't trivial matters, as you can imagine, and the tendency for companies like ours in the past is just to focus on the technology. And of course, you have nothing to offer without the technology and the licensing, but this is where you meet your economic goals and you make your shareholders happy, and that means you can stay in business. And then finally, I'll mention real quick the new frontier. I call it the new frontier market, which is the distributed power market. And this is what we all dream about in terms of developing countries that have smaller grids, and we couple with renewables perhaps. So the sky's the limit. So there, project financing becomes an issue. I know the World Bank right now does not finance nuclear projects, but we really need to look into how we serve that market. Technically, we can do it, but it's and then of course the partnership structure gets a little bit more complicated to think through. So do you work with truly you'll need to work with the country that you're going into in terms of an ownership scenario, but you're really looking at a build, own, operate, manage, and then you want to also be cognizant or realize that you're going to have to and you want to localize in those situations, localize with the local supply chain, and then that that also brings about some issues that need to be worked through. So these are some of the aspects that I'm looking at. The other one is briefly, we talked about the X-energy capital raise, but if you look at this from an investor point of view, investors really they look at the bottom line and how they can actually not only recoup their principal they put in, but how can they get a return. If you're looking for debt financing, they're looking basically, obviously, to preserve their capital that they deployed into you, and looking for their interest payments in return. And so their whole thing is risk. And so we've looked at this and continue to look at this. And there are a few things that are recurring themes, one being, does a country area where the project will be located, is public policy supporting nuclear energy? That's a big deal. Public perception of your project. The public can basically shut your project down regardless of your economics or regardless of your technology. And then the big one being the regulatory, the licensing and permitting. From an investor standpoint, as they look at these projects, they're saying that the regulatory in general, licensing specifically, becomes a risk that is not 100% under your control. So if we look at this with our two projects, the Xe-100 projects that I described earlier, the ARDP project, that's the Energy Northwest, and also the OPG, I think from a public policy standpoint, what we've been told from our investors is that they have high confidence that we'll meet this risk, and this risk is mitigated. Both of these, again, Canada has a carbon tax. They're very aggressive in terms of their SMR roadmap. They have an action plan. The government and provincial government are all behind SMR deployments. And Washington State in the United States happens to be one of the most aggressive in terms of their policy. They've got what's called the Energy Transformation Act. They're talking about eliminating all their coal facilities by 2026, and therefore you get they're looking at a zero carbon electricity by 2045. And quite frankly, you can't get there with renewables. I mean, they have access to hydro, but even that becomes a big impediment, basically looking at where the hydro's coming from, and to build any more hydro facilities is just out of the question from an economics. So SMRs are really important to that state. If you look at public perception in Washington State, the community loves us there. They really, really see this as the way to go. In fact, the labor unions are actually really supportive as well. They've become one of our biggest fans there. In OPG, for example, the Darlington project, there's already as you probably already know, there's already a nuclear facility at the Darlington site. So that particular area is they see the job creation and economic benefits of the SMR, and in terms of their whole country approach to clean energy, it's something that they really like. So I think from an investor point of view, I think we're good here with public perception. And then finally, and I talked about this earlier, the NRC, we right now are in pre-licensing discussions with the NRC. And our thing is right now to give them the best application possible. And as opposed to just giving them an application, getting into the system and having to respond constantly to questions. Our aggressive timeline is an issue there, but we believe we have a plan to meet that. Again, at Washington State, we're looking at 2027. And for OPG project, they have, well, with the CNSC, the CNSC has experience with high temperature gas reactors, and Ultrasafe Nuclear also has a project there, and they've been working with the CNSC for years. And they have what's called a vendor design review. So actually OPG is the one that gets the construction and operating license. You can't license your design there. So the VDR, as they call it, is more, I think, of independent government check on your technology. And so we're hopeful there that we'll get through that. So from an investor point of view, I think this is a medium to high risk, but the most difficult. And I just wanted to show you here that each standard plant, construction jobs, you're looking at about 1,000. And we covered this earlier in operations. We're looking at, roughly, let's say 100. We're trying to get it down to 80, 85 or so now. And finally, as you can imagine, with these aggressive, timelines with our projects, we have tremendous staffing needs right now. We looked at this. We probably need about 100 or 480 FTEs. I think of that, we're looking at around 300 or so engineering. All sorts of issues trying to bring that many people on board as quick as we need them. So we're doing a lot of outsourcing to meet this need because, we're not looking at inexperienced people. We're really looking at having experienced people. And in some cases, we can take entry levels, but for the most part, we need experienced folks. And if you look at the number of nuclear engineers here, these are approximations, obviously, but our plan was 75. Nuclear engineers are hard to find, experienced ones, especially in high temperature gas reactor technology. So we are constantly looking for good folks is the message here. And I think the biggest delta or change from maybe the traditional facility, the traditional nuclear is looking at the number of business people and the number of financial types that we need in order to, again, deal with this commercial sphere that I showed you and some of the issues there. Very important, especially when you look at supply chain with contract managers and program and project managers. If you look at someone like me with an engineering background, you tend to sort of say, well, these things can take a step back, but these are really going to be important people in order for us to be successful. And so, having said all that, that's all I had to share with you today. I hope it was beneficial. I do apologize for my time limitations, and traditionally we like to take questions, but maybe if you can send me questions or whatnot, I'll make sure and turn them around for you. Sorry, I can't hear you. Sorry, I'm not able to hear you. Thanks.
Sorry. Thank you very much, Jeff. Thanks a lot for your fantastic presentation. It's great to see all achievements of the Xenergy towards the deployment of the advanced nuclear reactors. I think that since you are so ahead, this is your case, it's very important also to hear and to see the experience and lesson learned also for our EU colleagues and for all nuclear community. who is thinking about the advanced nuclear power. So yeah, it was very nice, very long presentation, but still we have one question, if I can, one question, even though that we are a little bit over our limit. So there is our colleague asking, I will interpret this question, how about the possibility to replace the diesel engines in the big ships for the long distance? I mean, again, to save some environment. So it would be possible for your type of reactor, please?
Yes, very good question. Thank you. Yeah, I think not for the Xe-100, but for the Xe-1, yes, for the mobile reactor. And I believe that transportation is a huge market for us to look at, and we're definitely going to look at doing that. So yes, I think you are absolutely correct. Thank you very much. Having said that, I do appreciate the opportunity, and have a great day and what's left of it, and we will talk soon. Please send me the questions if there are any more.
Sure.
Okay.
Okay.
Thanks.
Thank you very much. Thanks for your time. Thanks for the presentation. Thank you.
I know.
And thank you to the audience for listening.